Okay, number 5, we're skipping number 4. Number 5, I created a very similar problem here. Each one of these has a square root. We can see that here and here. And each one of these has a number or a coefficient of sorts out front, like a -3z or a -2x squared. And then a whole bunch of stuff on the inside. Okay, so when we solve this, we actually break this apart. And the very first thing that I'm going to focus on is just going to be whatever is on the inside. I don't want to worry about the outside yet. I want to worry just about what's on the inside and how to break that down. And so I'm looking really at the problem, square root of 8x to the 4th, y to the 10th, z to the 5th. Okay, is 8 a perfect square? No, it is not. And I'm going to factor that so that I can get a perfect square out of it, one of those perfect squares being 4. And so if I just factor out the inside, what is the square root of 4? Well, that's 2. And so now everything that's going to be remaining there, this 2 is going to remain, and then we're just going to keep our letters exactly as they are. So I'm just focusing on the inside. I am purposely ignoring the -3z on the outside. Square roots now. Now I can actually look to this part and group those numbers, those variables by groups of 2. Remember, x squared square root just gives us x. So we want to kind of cancel out some things on the inside. So let's see, we're going to have 2 groups of 2 there. And then how many groups of 2 am I going to have for y? And I have 2, 4, 6, 8, 10. And how many groups of 2 for z? Well, I'm going to have 2 of them, but we're going to have 1 left over. Let's make sure to include that. So this whole thing breaks down into look something like this. You may find some shortcuts at some point. This is how I think about it. And now when I square root any one of these, this, those exponents are going to cancel out just like we would right here. So the square root of x squared turns into x, y, 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 z, and z. So all those perfect squares are now going to come up front. The 2's already out there. How many x's now? 2 of them. How many groups of 2 for the y? 1, 2, 3, 4, 5 of them. How about the z? 2 of them. Was there anything left over on the inside? Of course, we have a 2 and we have a z. That was it. Now, this is not our final answer because remember that I am just looking at the inside right now. What did I intentionally forget about? I forgot about that -3z. So let's bring that back in here. Now, you could just write it as this, as like -3z and all this kind of stuff, but that's not simplified all the way because now I got 2 z's out front. Well, what's z and z squared? Z to the 3rd. And what's that -3 and that 2 going to give us? That's -6 because we're multiplying. So this whole thing gives us -6 x squared, y to the 5th, z to the 3rd power, all times the root of 2z. So when you're doing this problem, think about reducing the inside first with your perfect squares, and then whatever you have on the outside, then you can make that final step of combining those 2 things together.